Hello, this is Dakota from section C0801, and today I'll be going over how to test for symmetry. But before I do that, I would like to apologize in advance for any background noise, as well as any shakiness of the camera. It's not my intention to give you a headache, but please bear with me and I will do the best that I possibly can for you. Having said that, let's get started with a little bit of background information you ought to know first. So, for x-axis symmetry, a graph is said to be symmetric with the x-axis if for every point xy on the graph, the point x negative y is also on the graph. Also, a graph is said to be symmetric with respect to the y-axis, that one right there, if for every point xy on the graph, the point negative xy is also on the graph. Lastly, for origin symmetry, a graph is said to be symmetric with respect to the origin if for every point xy, the point negative x negative y, down right there, is also on the graph. And to test that, what you need to do to test for all three of those symmetries, I'll explain right now. So for x-axis symmetry, what you need to do is replace any y's with negative y in the equation, and if by doing so you end up with an equivalent equation to the one you started up with, it has x-axis symmetry. For y-axis symmetry, what you need to do is replace any x's with negative x in the equation, and if by doing so you end up with the same equation, it has y-axis symmetry. For origin symmetry, you got to be careful because what you need to do is replace both the x and the y with negative x and negative y in the equation. And if when you do that, you end up with an equivalent equation to the one you started up with, it has origin symmetry. So there is our problem right now that I've been assigned to give to you. X squared plus y minus 4 is equal to 0. So first I will test for x-axis symmetry for no particular reason at all, just the one I chose. Now remember, to test for x-axis symmetry, what you need to do is replace the y with, right there, with a negative y in the equation. X squared stays the same, plus a negative y in replacement for that y right there. 4 minus 4, is equal to 0. X squared stays the same, minus y, minus 4 is equal to 0. So, looking at the original equation, we have x squared plus y minus 4 is equal to 0. In checking for the x-axis symmetry, we ended up with the equation x squared minus y minus 4 is equal to 0. So right here we had plus and a minus. These are not the same equation even though they are close, so this means that we do not have x-axis symmetry. So no x-axis symmetry. Now next I will test for y-axis symmetry. So in this case, what I'm going to do is replace any x's right there with negative x in this equation to test for y-axis symmetry. So right there we'll have negative x squared plus y minus 4. Doesn't much look like a 4, but I guess it'll have to do. 0 is equal to 0, excuse me. And all this means, I assume you already know this, but if you didn't already, here you go. A minus x and a minus x. 2 copies is what minus x squared is equal to, plus y. You know what, I'm not going to write that. I can just bring that down later. Just assume that you know that that's coming down. So when you multiply those two together, x squared plus y, that's a y, people. Work with me. Oh, see, those look too close, so I guess I will have to make this a little nicer for you. Just know that right there is a y. That's a negative 4. Maybe it'll help if I add that little n to it. Not really. So anyways, we ended up with x squared plus y minus 4 is equal to 0. And notice from the equation that we started with that we ended up with the same one over here after switching that x for negative x down here. That means that we have y-axis symmetry. And by the very definition of not having x-axis symmetry and having y, that means that origin symmetry is not possible, but I will show you how to test for that anyways, because you need to know anyways. So what you need to do, as I said before, earlier in the video, is switch your x's for negative x, and your y's in the equation for negative y. Minus 4, it stays the same all the time. So you're left with x squared plus 4, excuse me, y, looks like a 4, minus 4 is equal to 0. Excuse me, scratch off what I just said right there. When you have a plus, a negative, that becomes minus. That's a minus sign, not a positive. And so the x ends up the same, but the y doesn't. It's positive right here and ends up as a negative over here, so no origin symmetry after we've tested for that. So, in summary, we started off with the x-axis, and when we substituted the y for negative y, we ended up with a negative down here, so no x-axis symmetry. When we substituted x with negative x for y-axis symmetry to test, we ended up with the same equation, so we ended up with a yes, there is y-axis symmetry. And for origin, because there wasn't x-axis symmetry, but we did have y, there's no origin symmetry. And that concludes the video. So, congratulations for hanging in there. I hope that this was helpful to you in some way, and I wish you the best of luck on your next exam, test, or quiz. Not that you'll need it, of course. With that said, thank you for watching, and have a fantastic day.